Welcome to this podcast brought to you by the Vatican Observatory Foundation. I'm your host, Bob Tremblay. I'm a volunteer NASA JPL Solar System Ambassador, the first Vice President of the Warren Astronomical Society in Michigan, and an Internet factotum for the Vatican Observatory Foundation. This podcast comes from a recording of one of our monthly full moon meetups with Vatican Observatory staff and Sacred Space Astronomy subscribers. Sacred Space Astronomy is the Vatican Observatory's online community. We have several astronomers and scholars who write articles on our website about astronomy, space science, and faith and science. Every full moon, the Vatican Observatory Foundation hosts a Zoom meetup for our Sacred Space Astronomy subscribers. Typically, our guest will be a member of the Vatican Observatory staff or an affiliated researcher, and they'll tell us about their research and what they're doing and the journey that led them to the Vatican Observatory. Brother Guy Consolmagno, director of the Vatican Observatory and president of the Vatican Observatory Foundation, will talk with our guest, and our Sacred Space Astronomy subscribers can ask questions. This podcast was taken from the Full Moon Zoom meetup on Monday, January 17, 2022. Our guest was Bill Higgins, an engineering physicist who works on radiation safety at Fermi National Accelerator Lab, Fermilab, a particle accelerator near Chicago. In his spare time, Bill loves to learn about spaceflight, astronomy, and planetary science, and as a volunteer NASA JPL Solar System Ambassador, he shares that knowledge through lectures and writings. Bill has been a mutual friend of Brother Guy and myself for decades. We share a large group of friends in the science fiction community.
Bill and I go back a long, long ways. One of the earliest moments I remember, and we probably met earlier than that, was in 1980. I was a postdoctoral fellow at MIT, and he had come with a group of mutual friends, including an old roommate of mine, to the World Science Fiction Convention in Boston that year. And I gave them a tour of the tunnels underneath MIT, trying to get them lost. And after every twist and turn underneath, crawling underneath all the buildings, I would say, all right, which way's the river? And as I recall, Bill, you were able to remember every turn until we got to the dome where the engineering library is. And after walking around 1 3/4 times, we were all dizzy. Is that the way you remember it?
More or less, yes. It was a marvelous tour.
Yeah. Besides being a science fiction fan, Bill has a day job at Fermilab. And can you describe to us what you do?
I am a radiation safety physicist. So I am part of a group that tries to keep people in radiation apart and minimize radiation in the environment. My job, I do some miscellaneous things, but most of my time is spent thinking about shielding. We have concrete walls or buried steel or lots and lots of dirt here and there. We have miles and miles of tunnels. So and there are particle beams running through vacuum pipes all through these tunnels. We have the potential to produce radiation. So a shower of particles, if the beam hits something it's not supposed to hit, and we have to make sure that we would be safe if that kind of accident happens. So this job would be very easy if it was all buried in thick shielding, but it's also true that all that equipment down in the tunnel, like magnets and vacuum pumps and sensors and radiation detectors, all needs it needs wires, it needs pipes, it needs vacuum lines or cryogenic lines, and so there are holes in the shielding, and we have methods of calculating the passage of radiation through holes and around bends and so-called labyrinths and so forth. So we need to understand the dose that could potentially come out in an accident through any given hole, and we have databases and spreadsheets for that kind of stuff. So
have you ever had the chance to have to tell some very, very important scientist with a very, very important billion-dollar program, sorry, no, you can't do that?
Yes. It is. Actually, all of this stuff would be a lot safer if they just didn't run their beams. Okay. So, but I had a wise boss I learned this trade from, and he kept reminding us that our job is to help people get their experiments done. And so my attitude is always, we found a problem here. Can we think of ways to mitigate it? And there were a bunch of techniques, and sometimes you have to bring bad news to the experimenters, but at least it's a mutual discussion about, well, what if we do this? What if we do that? And there might be a delay of a month, or there might be some extra money that somebody needs to spend, or there might be some extra cleverness that we are called on to think of. But those are the challenges of the job. And sooner or later, we get most of this stuff done, and then somebody publishes a paper. But I'm one of many behind the scenes people, like the Vatican telescope. We have lots of people thinking about water and power and vacuum and logistics of bringing supplies, let's say liquid nitrogen to places where it's needed, and all that kind of stuff. And none of those people get their names on the particle physics papers, but all of those people are pretty essential to making it to making it happen. So I have a deep feeling of sympathy for the folks on your mountain.
How long have you been doing this job?
I've been at Fermilab since 1978.
Oh my gosh.
Yeah. This is not the only thing I've done there. Like, I was hired to make neutrino beams, and I did that work for some years. And so I have a background operating the beam lines, shepherding the particles as they go from the big accelerator, and new particles get created, and we try to deliver them to experiments a couple miles down the pipe. And that was a good background to have when in the early 90s I was asked to become a safety guy. And I already knew the ropes, I knew the systems, I knew what it was like to be on the other side of people needing to deliver the beam, and waiting impatiently for the safety people to bless their work and so forth.
So that's all fascinating stuff. But of course, we're a bunch of astronomers and astronomy fans. And the reason I actually have you on here is because I know you've got an interest in astronomy. Where did that start?
I wanted to say that all the opinions I'm expressing about Fermilab are mine, and not the opinions of my employer, Fermilab, or the Department of Energy that Fermilab is a contractor for. So you're listening to me, not to anything official.
And likewise, I don't speak for the Pope.
Right. Okay. It's
so tell me, you've got this. We're here because we're all interested in astronomy. Let us know a little bit about how your background in astronomy. How did you get interested? Where did you grow up? Who first showed you the stars?
I was born in Rochester, New York. When I was 8, I moved to Detroit, Michigan, and so that and I guess when I was in the 8th grade, or we moved to Miami, Florida. So I've been around. I've sampled the public libraries in a number of those towns. That's an important influence on my childhood. And I got interested. I guess I started as a maybe 4 or 5-year-old guy, interested in machines, fire trucks and airplanes and things that made noise. And as I learned more about cool machines and fast vehicles, I realized that what made them work was science, and that one needed to understand science and engineering in order to understand this wider world of technology. And so that was kind of my doorway as a child into science. And it was, we're talking sort of 1960 or so here. It was the space age. It was the atomic age. It was also the age of plastics. And by about the age of 7, I was convinced that being a physicist was a cool thing to be, and maybe I might want to be one of those guys. But I also loved spaceflight and astronomy. It's all one big ball of fun, and people were launching Russian and American folks into space, and submarines were going under the North Pole, and I just love to learn about it.
the thing that I find fascinating is you've got this, science background, you're working at Fermilab, but you have a completely different life as a NASA solar system ambassador. Can you explain to us what that's all about?
Near the end of the 90s, NASA started a program. They kind of figured out the following fact, which is probably known to everyone here. In every town, wherever you go, there is at least one person who loves astronomy so much that they'll put together some slides and go give a talk to a public library or a school, or they'll drag their telescope out and let the public look through it. It's a set of missionaries, really, I guess. And because there are people like that all over the place, NASA started a program in which they would recruit such people to share information about NASA programs with the public. It started with the Galileo mission, I think, and then they broadened it to many other programs, and there's a lot of them involved now. And this has been going for more than 20. I've been a solar system ambassador for more than 20 years. You are obligated as a volunteer in this to do at least 4 quote events unquote a year in which you contact the public in some way. I give talks a lot, but people might choose to do something else, set up an exhibit table down at the shopping mall or something like that. And the volunteer says at least 4 times a year in my community, I will do some stuff that shares information about NASA with the public. And NASA, no money changes hands. These people are all doing it on a volunteer basis, but NASA provides briefings pretty frequently, like teleconferences where we, as the ambassador volunteers, can get a presentation from a scientist involved with a mission, or an engineer who's operating it, or an educator who's got some new product that you can share with the public. And like I said, these people already existed. And NASA is just getting the benefit of their existence.
So how did you get into this public outreach in the first place? Was it school or what?
I always liked telling people something cool I knew about science. And so I am one of the people who was already doing this kind of stuff when NASA figured out at the end of the 90s that it was a good idea.
Where would you do it?
I think I would say my career, if you neglect some chalkboard talks about atomic energy that I was asked to give to my 4th grade class, then the real start was about 1984, when I realized I knew about some cool stuff, and I was regularly attending science fiction conventions, and even sometimes getting involved in helping run them. And I realized people give talks about stuff at these conventions. They sit on panels and discuss topics. Maybe I could give a presentation about a cool thing I'm interested in. And I did a talk. I learned how to make slides out of images in books. And I gave a talk on the romantic age of rocketry, the early development of rockets in the beginning of the 20th century, before it kind of got professional. I was off and running. I gave that to an audience at Capricorn, I think, in Chicago around 1984, and I kept coming back with new topics. I was reading Aviation Week. I was, paying attention when there were professional speakers coming through my lab. I read books, and I could, do a little homework, and I knew enough physics and astronomy and a handful of other sciences to kind of understand technical material about a space mission or about a planet or something, and then turn around and explain it in, one hopes, clearer terms to anybody. There
are 3 topics that you've done that I would never have heard of except for your talks. And can you give us, a 2-minute summary of what the heck is a Jacquard loom and why does it matter?
Yeah, well, I'm also interested in the history of science, which is a natural branch off from reading all those books about science and technology as a kid. Okay, And the Jacquard Loom is the scheme invented around 1800 in France for taking away some of the tedious work of making an exact pattern when you're weaving something. It's a regular loom with a mechanism added to read or to feed in the punch cards with holes in them and have those control which hook is lifting up which thread in your loom. And if you have enough of these cards, you can make a beautiful pattern, and you can reproduce this pattern over and over because you can use the cards over again the next time you set up the loom. And okay, so well, that's a Jacquard loom, right? Computers, as we understand them, were invented basically in the 1940s. But there was a guy in the 1830s who had a vision of this stuff, Charles Babbage, who was a polymath who did many, many other things. But Babbage had this idea that maybe machines could do computations. And he designed some machines to do calculations. And he looked around, and the weavers were using the Jacquard loom, and he decided that that would be a good mechanism to feed information in his machines. He never built the machine that would do that, actually, but it's a great what might have been of history, and I love might have beens of technological history. So I got interested in the Jacquard loom, and I wound up. There's a I can do 20 minutes on this,
right?
But there's a PowerPoint.
One of the things that, of course, many of us on this love to do is watch old movies, old science fiction movies. Last night we saw an episode or two of Zombies of the Stratosphere, which was a serial involving aliens, including a very, very young Leonard Nimoy invading the Earth. And our hero had a rocket belt. What can you tell us about rocket belts?
A rocket belt is the name that Bell Aerospace gave to the jetpack. Any of us would call this thing a jetpack, a backpack with rocket motors attached to it. But for some reason, they decided it was a belt in Niagara Falls, New York. So the rocket belt first lifted a person into the air for an untethered flight in April of 1961. So just about the time I was becoming attentive to news and information about the future and so forth, here was this thing flying around that was a wonder of the age, right? And so I was always interested in the rocket belts, and I wrote a little bit about them on the internet in the 80s or 90s or something. But in 2006, I learned there was going to be a conference to celebrate the rocket belt, and they brought together the old engineers and test pilots who had been involved with the original rocket belt with a bunch of people who were building new rocket belts in their garages. So I got to be, for one weekend, I was with the jetpack people, and I learned a lot about that, and enough to, go out and make a talk and explain the jetpack.
So they actually built these things that people actually flew with them?
I met the guy who flew the first one.
How long? How far?
Not long and not far. It's a marvelous device of an elegant design, and it works very well. But the propellant that a person could carry is all the propellant you got, and this is enough. This heavy thing on your back with the rocket engines attached has enough propellant to keep a person in the air for at most about 30 seconds. A really safe flight is about 20 or 22 seconds. This is really not a very practical flying machine. And Bell tried to find ways to extend the flight and tried to find ways that persuade armies or police forces or whatever that they really needed something that would fly a person for 20 seconds. There was about a decade where they were trying to promote this thing, and they swapped in a jet motor at one point, and that could fly somebody for 3 minutes, but that's still not very practical. And I just, it didn't work out. But there was one thing the rocket belt was good for, and that is everyone loves to watch it. So if you can always get a crowd to watch a rocket belt guy fly. And so this was a tremendous public relations tool for Bell Aerospace. And the rocket belt guys flew at Disneyland and flew at supermarket shopping mall openings and whatnot all around America and sometimes other countries throughout the 60s. And it left a bunch of young people who were so fascinated that eventually they wound up building their own copies of the rocket belt. Not many of them, but the rocket belt had a second life in the 1980s and flew before President Reagan and a crowd of thousands at the opening of the 1984 Olympics. I met the guy who did that.
You're talking again about public outreach and public connection, and this is something you've been doing now for nearly 40 years. Over that time, what's the most common question you get, especially if it's an astronomy related talk?
I really can't think. There's not anything that pops out as a question I'm tired of hearing because I have to answer it over and over again. In fact, I give talks to crowds of people. Some of them know a lot about astronomy. Some of them know a little about astronomy, but they're all smart people who ask thoughtful questions. And even when it's a question that shows a lot of ignorance of the scientific principles, it's usually a sensible, logical question to ask. So I can't really say there's been anything that's common. The most recent version, or commonly encountered question is when you tell people a lot about the James Webb Space Telescope, they will ask, can people fly up and fix it if it breaks?
Yes.
The answer is it's not designed to be fixed that way. They instead chose to design lots and lots and lots of reliability and testing into it, and we all crossed our fingers. The James Webb Telescope will run out. It requires, unlike the Hubble, for complicated reasons, requires propellant. So it's going to use up its fuel someday. Even if it's all working, it would be nice if somebody could refuel it. And that seems like not completely impossible, but it's certainly not designed to do it.
You're interested, we're all interested in the space missions. I'm envious because you got to do something I never was able to do, which was to be there at a critical moment in a space mission. Can you tell us about that?
I was fascinated, as I guess probably everybody was, with the Voyager missions. The Voyager 1 and Voyager 2 launched in 1977 and took advantage of a special alignment of the planets so that they could actually visit 4 different giant planets between the 2 spacecraft and go to Jupiter and use Jupiter's gravity to bend your course to go on to Saturn, and from there Voyager 1 went off into deep space, and Voyager 2 went on to Uranus and then to Neptune. It was a fantastic thing, and every time there was a mission, I would hear that they would sometimes invite science fiction VIPs and other science world characters to come to the Jet Propulsion Laboratory during the days of the planetary flyby and get a glimpse of Jupiter in detail or Saturn in detail, and it sounded really exciting. And I kept hearing the stories of people that had done this, and I really decided that I wanted to be one of those people. And after the Uranus encounter of 1986, I began to scheme to somehow get to be there when Voyager flew by Neptune. I couldn't be at Neptune, but I could be in California maybe if I knew the right people or pulled the right strings, or somehow privilege smiled upon me or whatever. And I managed to find that the National Space Society was running a kind of journalistic operation to cover the Neptune flyby in a most peculiar way. And I argued that what I just said before, I can understand the science about this stuff, and I can turn around and explain it to the public. You need a guy like me on your team. And they said yes. So I went out to Pasadena, and I joined the seasoned National Space Society reporting people on an operation called, well, let's see. Do I want to tell this story at length? I don't know.
Yeah, sure.
Okay. Yeah. The peculiar operation was this. They ran once upon a time there was something called 900 numbers. The area code 900 telephone numbers were introduced. I don't know. I guess in the 80s. It's an 80s thing, where for services where you would call this number and you would pay so many cents a minute in order to enjoy the service. It's like if there was somebody who was providing recorded jokes, you could dial in, listen to a couple jokes for $1 a minute, and you would hang up, and it would be added to your telephone bill. NSS knew that lots of people were interested in space, so they had an operation called Dial a Shuttle, where their people would set up in the press room, along with all the other journalists of the world, when a shuttle mission was going to fly, and they would have a phone line, and they would be continuously on the microphone or continuously playing tapes to explain what was going on in the mission. And when there was audio available between the astronauts and the ground, they would put live audio on the Dial a Shuttle line. And people who really, really wanted to hear more about the shuttle could listen to the shuttle astronauts talking. It was, and during periods when the astronauts weren't talking, the NSS announcers would explain the scientific payload of the mission or explain what the next spacewalk was going to be or whatever. So the decision that NSS had to make was, should we do this for Voyager Neptune? Because we've got an operation that we know how to do, but there are no astronauts aboard Voyager Neptune. It would entirely have to be people explaining science on the phone line. Maybe cover. You could run the press conferences live, et cetera, et cetera. And the staff would have to be people who maybe took the scientific jargon from the press conferences and wrote real quickly, wrote language into a kind of radio story that could be read and maybe recorded to explain Neptune's magnetosphere, or new discoveries about rings around Neptune, or what we learned about the moons that day, or what have you. And I was part of the team that was doing that. They were all really experienced at Dial a Shuttle, and I was newbie, but I knew some science, and I did a lot of homework beforehand. And I actually got to be on the Caltech campus during this, and I even made a visit to JPL, so I could say I set foot on JPL campus and heard their press conference during the Neptune flyby.
So, of these people and of these places, I know you've discovered and uncovered all sorts of wonderful events, places, museums. What's the 3 coolest places you've ever been to?
There's a cheap joke answer to that, because I was just talking about Neptune, and I loved that so much that I wanted to do the same thing. It took a lot of years, but somebody sent a spacecraft to Pluto. So I managed to get involved in outreach, this time assisting NASA and the teachers that were working for NASA for the New Horizons encounter with Pluto. And 2 years later, they found another target on an asteroid, technically a Kuiper belt object, which eventually got the name Arrokoth. And I showed up again and helped somebody else, Christian Reddy of the YouTube channel Launchpad Astronomy. I helped Chris do his live remote from the Arrokoth encounter, and that was a lot of fun. But it means that I've been to the 3 coolest places I've been have certainly, or I've experienced, have been Neptune, Pluto, and Arrokoth.
But here on Earth, you've the 2 of us, spent a couple of days in Florence, and after I had to go on, you found some bizarre museums there that I've never heard of. What are some of the real gems of museums that you would tell people about that we might not know about?
We we had bought the special card that allows you access to a whole bunch of museums in the city of Florence, and we had seen all the big ones, and I put you on the bus, and my card still had some days on it, so I just I was looking at other museums on the map. I had seen lots and lots of art, and I thought maybe it was time. There's another little science museum, a non-famous science museum here.
There's the famous one. There's the
that.
Galileo Museum, but
Yes.
we had already gone to that.
We had been
Right.
there. You showed me around the Galileo Museum. But there's something called the Institute of Science and Technology. And I said, what's that? And I went there, and it's a museum, and it has some rooms with some science stuff in them, some artifacts. And there was a room where they had like an elementary school class in, and the teachers were running them through hands-on exercises, like in so many science museums I've been to. But it was kind of small, and not that interesting. And I started, but it was all right. And I started talking to the person at the desk, and the person at the desk said, "Would you like to see the special collection?" And I don't know what it is about me that makes me look like a person who ought to be asked whether he wants to see the special collection. But if someone asks you a question like that, you say, yes. And she got out the big key and we went down the hall to a room where the door was locked, and she opened it up, and there was the special collection. It was fabulous. It was amazing. And the story is that in the 19th century, Italy was a country that was moving, as all countries were, from more agrarian to more industrial. It was the age of steam, right? Electricity was beginning to be important, and Italy was one of the countries at the forefront of the Industrial Revolution. But Italy needed lots of people to work the machines and design new ones, and engineers who would build dams and bridges and that kind of stuff. So there was a school that started to train young technical people, and for some reason, these folks had the resources to buy all of the very best laboratory classroom demonstration equipment that was made in 19th century Europe. The instrument makers of Paris or London or Germany sold these guys lots and lots of equipment to demonstrate electricity and hydraulics and optics and whatnot. And they quit using this stuff sort of at the beginning of the 20th century, maybe, and it's preserved. It's still there. Maybe some of it needed to be fixed up. I don't know, but in recent decades, they've fixed it up. And there's this vast collection of antique demonstration instruments, and all behind that locked door. And I wasn't allowed to take pictures of it, but I was allowed to wander through and admire it all. And it was completely fabulous. And then my guide mentioned that they had a YouTube channel. And the Institute has I think it's called Florence FST. And that YouTube channel holds, I don't know, 80 or so short videos where the expert curators take out these machines and demonstrate how a spark coil or the Chladni patterns of acoustics or lots of things work. So I wrote a series of little I don't know, glosses on the YouTube videos for the Vatican Observatory Foundation website some years ago, because They were just fun to do. I thought more people should see this wonderful work, these wonderful videos, and this is one small way in which I could share this cool discovery with more people. So I started. I haven't added a whole lot to what they to the beautiful work they have done, but at least I've drawn people's attention to it.
What I want to mention here is your outreach has been an inspiration to me to see how you will interact with different kinds of audiences, from school kids to smart aleck science fiction fans to the kind of gentle grown-ups who still build their own rockets and kind of show up with their rockets to your talk because they want you to be able to see what they've done. And your patience with, as you say, the questions that come from intelligent people who just haven't had a chance to learn has been an inspiration, but also the need and the ability to do outreach. The kind of stuff you've done is what got us into the business of putting together the faith and science resources that we have and the blog that we started. You were one of the early contributors to the blog.
That's a wrap for this podcast. Our audio editors were Brother Guy Consolmagno and myself, Bob Tremblay. You can listen to our other podcasts and read our posts on the web at vaticanobservatory.org. If you'd like to attend our full moon meetups live, join our Sacred Space Astronomy community, also at vaticanobservatory.org. Clear skies, everyone.